Specific heat problems. A 15.75 gram piece of iron absorbs 1086.75 joules of heat energy, and its temperature changes from 25 degrees to 175 degrees Celsius. Calculate the specific heat capacity of iron. Mass is set 15.75 because you look for the gram unit, and once you see gram unit, you know it's the mass. Q, the heat is the heat energy, and as soon as you see the joules, you know Q is 1086.75. It says the temperature changes from 25 to 175, so it's 150 degrees Celsius. And the specific heat will therefore equal, we have mass, we have delta T, we have Q, we don't have C, you plug it in. Now we solve for C. C equals Q over MT, or C equals 1086.75 divided by 15.75 times 15, and that gives you 4.6. How many joules of heat are needed to raise the temperature of 10 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.90 joules per gram per degree Celsius? Q equals MCT. Mass is 10 grams. Looking for grams. Delta T is equal to 22 minus 55. We always use a positive value. C, which is a specific heat, is 0.90. So Q equals MC delta T, 10 times 33 times 0.9 equals 297 joules. Calculate the heat capacity of a piece of wood. If 15,000 grams of wood absorbs 6.75 times 10 to the fourth joules of heat, and its temperature changes from 32 degrees to 57 degrees Celsius. Q equals MC delta T. The mass is 1,500 grams. The Q is, in scientific notation, 6.75 times 10 to the 4, but we know that's equal to 67,500 joules. T equals 32 degrees, so the difference is 25 degrees. Plug the formula in, and C equals 1.8, because we know the formula is C equals Q divided by mass times the change in temperature. Yay. You have 100 milliliters of 4 degrees Celsius water. It is heated until its temperature is now 37 degrees Celsius. They're changing the wording, so just be careful. The same rules apply. If the specific heat of water is 4.18 joules per gram per degree Celsius, calculate the amount of heat energy needed to cause this rise in temperature. Mass is equal to 100. Since 100 milliliters of water is the same as 100 grams of water, because the density of water is 1 mass gram per milliliter. So anytime you see a milliliter of water, you know it's equal to a gram of water. Temperature change is equal to 4 to 37, so it's 33 degrees. You know the specific heat is 4.18, so then the formula becomes Q equals MCT. So 100 times 33 times 4.18 equals 13,794 joules. Number 5, 25 grams of mercury is heated from 25 degrees Celsius to 155 degrees Celsius, and it absorbs 455 joules of heat in the process. What is the specific heat of mercury? Mass is 25. The temperature change is 130. Always use a positive value for now. Q equals 455 joules. The formula becomes 455 divided by 25 times 130. And the specific heat becomes 0.14. Because we know when you're solving for specific heat, it's equal to Q over M times delta T. What is the specific heat capacity of silver metal? If 55 grams of metal absorbs 47.3 calories of heat, and the temperature rise 15 degrees. Be careful now. They changed the units on you here. They're using calories instead of joules. So just be aware of that. It's the same thing. Mass 55 grams. Q equals 47.3 calories of heat instead of using joules. Temperature is 15 as rises is a change in temperature. So when it says the temperature rises 15 degrees, that's the change in temperature. The specific heat equals the value of the heat energy, Q, divided by the quantity of the mass times the change in temperature. So C equals 47.3 over 55 times 15, or C equals 0.57.